Hello everyone, welcome to this video. And in this video we're gonna solve this question using a method called magic substitution or Z substitution. Magic substitution, or others would call it Z substitution. And the reason why it's called Z substitution because you make a Z substitution where you say Z is equal to tan x over 2. And of course, the other parts of the substitutions are going to follow that. You're going to say sine x is going to be equal to 2. And this is 2z over, then we have 1 plus z squared. The other substitution you can make is cos equal to 1 minus z squared. Then you have 1 plus z squared. Then of course dx, which is going to be, so you have dx being, okay, so you're going to have dx to be equal to, so you have 2 over 1, then you have plus z squared dz, like that. So these are the substitution that you make into your integral. And we see here that we have the integral given as 1 over 5 plus 4 sine x dx. So meaning we can replace our dx and we can replace our sine there with what we have here. Okay, so we're going to say that the integral of 1 over 5 plus 4 sine x dx is just going to be equal to the integral of so I'll say 1, then 5 plus, so the 4, then where the 4 is, we're saying sine x is 2z over 1 plus z squared. So I'm going to say 2z divided by 1 plus z squared. I close that there. Then of course this is multiplying by the dx. Dx is just here, and the dx is 2. This is 2 divided by 1 squared. 1 plus z squared dz. So this is going to be 2. Then we are dividing by 1 plus z squared. Then we have our dz there. Okay, so what do I do next? I can then multiply this here. So I expand what's there down. So I'm just going to have 1 over, then I have 5, then expand there, then I get 8. So I'm gonna have 8. So that would be plus 8. That would be 8z. Then after the 8z, then I'm going to okay, so 8z, we're saying 8z, then this is over 1 plus z squared, like that. Then you're multiplying by the 2 over 1 plus z squared dz. Next step, I want to make this here into a single fraction down there at the bottom. So I have the integral of, so this means that this is over 1, this multiplies with that. I have 5 multiplying by 1 plus z squared, then I have a plus 8z, then all divided by 1 plus z squared. So this is what I have. Then of course, still multiplying by 2 over 1 plus z squared, then I have my dz there. Okay, so what do I do next? So I can see that this here in the bottom, I can divide the 1 plus z squared, 1 plus z squared, that goes. So when that goes, what do I remain with? So let me erase this part. So when that goes, I just remain with, okay, so that is just going to simplify to be the integral then of, so this 2 multiplies with the 1 on top, so I have 2 there. Then what remains there in the bottom, and that is just 5 multiplied by 1 plus z squared, then plus 8z, then of course my dz, which is there. So I have my dz there. Then I can expand, of course, what is down. So I have 1, expanding that I have 5. So I have 5, and I'll have plus, that'll be plus 5 again, 5z squared, then I'll have 8z, like that, then dz. So this is what I get. So now after getting this, what do I do next? So next, I want to complete the square. So to make sense of what's there, I want to complete the square, which is down there. So how am I gonna do that? So let me get it. I write it here separately. So I write the 5, so I have 5z plus 8z, then plus 5 there. Then I complete the square on this. Then I just have factoring out the 5, since that's leading coefficient of the highest power, highest degree there of the polynomial. Then I am going to have that I remain with z squared there. Then I'll just have plus 8 over 5 z, then plus my 1 there. Okay, then from here, I continue. I just say this will be 5. Then I complete the square now on z. Then that will be just z. So that will be z plus half. I take half of the coefficient of z, and that multiplying by half there is just going to give me 4 over 5. Then I close square. Then I square the 4 over 5 like this. So that's 4 over 5. Then I square it. Then this just gives me, and subtract it, of course. I subtract it. Then I get 16 over 25. Then I'm adding plus my 1, this 1 here. Then this here will close up like that. Okay, then from here, I'm going to remain with the 5. 5, what else does remain there? So 5, then here, z plus 4 over 5, then squared. When I add this to the 1, which is there, I just get that this is going to be plus 9 over 25, like that. So this is what I get. Then from here, I can multiply the 5. So this implies this is just going to be 5 multiplied by z plus 4 over 5, then squared. Then from there, when I multiply the 5, to divide into this 25. So this 5 there divides into that 25, giving me 5, and I have plus 9 over 5. So I get 9 over 5 there. Okay, so now this is what I get in my bottom. Then I can replace it here. So I just say that would be 2. Then I replace. So when I replace, I just have 5. So I have 5 over z plus 4 over 5, then squared, plus my 9 over 5. So this is what I get. So, okay, not forgetting my dz here. So now we continue with this. From there, the next thing that we do is so the next thing that I'm going to do here, so you can see that you can just remove, or you say we want to factor out this 9 over what, over 5, such that I have a 1 there. So how am I going to do that? So okay, I factor out that 5 over what, over 9. So factor out the 5 over 9 here, such that I should remain with a 1. My aim is to, in order to see something in terms of tan, because you know when tan is written as x squared plus 1, so let me get the 1 there, and that's by factoring out the 9 over 5. So I get 2 there. Then if I factor out here 9 over 5, then what do I get? So in the first part, I am going to get that when I factor it out, I have 25 over what? I'll have 25 over 9, because here 25 over 9 just gives me the 5, which is there. So I get this in the first part. And of course, my z plus 4 over 5 squared still remains the same, like that. Then of course, my plus 1, since I've just factored out what this 9 over 5, when I multiply by the 1, it gives me the 9 over 5, which is there. So from here, we've just written it and factored out the 5 over 9. Nothing much has changed. Nothing has changed at all. Then from here, I see that I can multiply. So I can multiply this 9 over 5. Or this 9 over 5 just is the same as writing 5 over 9 in the numerator. So this is multiplying with the 5 over what? Over 9 there. Then I'm just going to remain with 25 over 9. Then of course z plus 4 over 5 squared plus 1. Then my what? My dz is going to go there. Okay, then what do we do from here? So from here, we see that we're just going to get, so here on top, I'm just going to have 2 by the 5 gives me 10, then divided by 9. So I just get 10 divided by 9. And I can factor that out. I can push that to the front. So 10 over 9, then my integral there, I remain with 1, then divided by, then what do I remain with in the bottom there? So what is it going to be in the bottom? So I have my 9 over 5. I have that there. And okay, so what do I get? So, okay, so you see that this here is just going to simplify to 9 over 5. If I get my 9 there, I just have my 5 over, is that 5 over 3 that I am seeing here. So, okay, let me just rewrite that. So let's write our 25 here. So write our 25 here over 9, 5 over 9. So remember here what we did, the step that we carried out here was just to bring the 9 over our system. You say that's the same as dividing by the 9 over 5, and that is the same as multiplying by what? So dividing by 9 over 5, that's the same as multiplying by 5 over 9. So that 5 there multiplies, then you remain with a 9, then you have the 10 over what there that remains. Then the next one, you have your 25. So 25, we're saying even here, we can say it's the same as we are dividing here, 25 over 9. Then this here can be written as 9 over what? 25. Then I have my 9 multiplying there on top. The 9 goes. So you see that here I can write this like this. So if I have 9 over, this is 9 multiplied by 25. So the 9 multiplied by 25 is going to multiply with what? With this here, which is there, which is the 10 over what? The 10 over 9. And I just get that I'll have front there, I'll have 10 over 9, then I'm multiplying by 9 over 25. Then the integral of 1 over, then you have z plus 4 over 5 squared plus 1, then dz there. So this here divides that here 5 2 times, there 5 5 times. So that's what I remain with now. Okay, so from here, what are we gonna do? So from here, we just have, since that's what remained, so we will have that this is going to be the integral of, so we said 5 over 2 over 5, then of course we remain with 1 over, that is z plus 4 over 5 squared plus 1. So this is what we have. So now from here, you see that you have this here plus 1, and just want to write that in terms of what? In terms of u, such that we are able to get a tan. So what am I saying? What I'm saying is I can let my u, so I let my u be equal to what? To this here inside, and that is just z plus, so that's my z plus 4 over 5. Z plus 4 over 5 be my u. I then differentiate, this is going to be du equal to what? To dz. This here becomes a constant of 0. Then of course I have my dz here. So I now replace, this will be 2 over 5, then the integral of, so what is that going to be? That is going to be 1 over u squared, then I have a plus 1. Dz is just equal to what? To du. Okay, then from here, what does this imply? So this then is going to leave me with, so when I integrate this, I just get tan inverse of what? Of u. So I get tan inverse of u when I integrate that. So integrate that there, so this is a 2. So I just get 2 over 5 like this. Then I have tan inverse of u plus my c. So now tan inverse of u plus my c, then I replace back my u. So I replace back my u. I have 2 over 5 tan inverse my u or z plus 4 over what? Over 5. Then I have a plus what? Plus c there. Then I know again I can replace back my z. My z is just tan. My z is just tan x over 2. So z, as we said, tan x over what? Over 2. So I can replace there where there is z. Then I have 2 over 5 tan inverse. Then where my z is, I'll replace that. So I have, that is going to be tan x over what? Tan x over 2. Then, of course, I'm just going to, after the tan. Okay, so I can write this as a single fraction, actually, before I even, I even replace my u, my z, I mean. So this here can be written as 2 over 5. I can write an inverse. Then I write that as 5z plus 4. Then I have over 5 here. So I can write it like that plus my constant c. Then I can replace, I can say 2 over 5 is just going to be tan inverse. Then I replace my z, which I know is that. Then I'm just going to have, this is going to be 5 tan x over 2 plus 4 over, so I have 4 over 5. So 4 over 5 is going to remain there like that plus my c. And here, this is where my question ends, and that's how I use the magic substitution or the z substitution. Remember, if you're new to this channel, hit the subscribe button for more. Follow, like, comment, and we'll see you in the next one.